So we will explore Solr and we'll see what it offers for us in the next 5 to 6 modules, and we'll end up with the Solr project. So what we're going to focus today on is basically getting introduced to Solr, understand what Solr offers and how is it different from traditional RDBMSs. We're going to do a small contrast of the RDBMS and how it is different from the traditional Oracle or MySQL, and we will just see how do we use Solr in a quick way, and we'll just walk through some of the admin UI components and getting some of the Solr insights on the architecture. We'll start with getting details into the schema and fields and types, and we'll also choose to do some introductory lab as well. Okay. So basically we have learned about Lucene, right? So why do we think we have to still look into a better one like Solr, even though the Solr is built on top of Lucene? Why do you guys think we should have Solr in our skill set, or why do you think we should even bother about looking into Solr? So what are the challenges you guys have seen working with Lucene, or Solr could give you a little bit better? Just without even understanding what Solr is all about, I'm just trying to understand what is it all about. Great. So the first thing is, if you guys have noticed, in Lucene we have to write lot of Java code, right? So for each and every small aspect you have to write Java code. So if you are trying to build an search application, something similar to what we have seen on Flipkart, so you may end up writing a lot of Java code. That's the first thing. Okay. The second thing is, say for example, if I'm trying to build a autocomplete, something like this. So you have to build this entire autocomplete, or sometimes we even call it as suggestions. So this feature, even though Lucene supports the raw APIs, you don't have any service as such where you can go ahead and build it, right? So you may end up writing 4 to 5 components and 4 to 5 applications to build something like this, and over the period of time it may get really tedious for you to manage all those classes, because as it may get bigger and bigger. And also the second thing is the scalability problem. So Lucene does not tell you how to scale your index, how to distribute your index, and how to manage your index, kind of a thing. So it just gives you a raw API, and that's where Solr comes in and helps us out in managing all these things for a large scale applications. So apart from what Lucene offers, Solr extends some of the features and it adds its own additional features, like it does provide the architecture to scale the search application for horizontal needs or for big data needs, and it provides separation of concerns, and on top of it, it also provides the complete wrapper of all the Lucene features on a service-based model. Basically, you don't have to write even a single line of Java code or any other coding. So all you have to do is use the Solr application and consume all the content or index the content using the REST-based web services, either XML or JSON, or there are a lot of other formats. So that's the beauty of it, and you can manage all the documents, everything, using the HTTP REST-based XML. So you don't have to interact with the index using the core Java APIs. We have seen this example already. So we have said we may require a search engine when we have something like this, the text-based search. So Solr might be appropriate when you may require a suggestion feature, which is a free text-based search, and when you need a lot of faceting and the content is based on the document-based store. So each item what we see on the screen is primarily referred as a document. Okay, so the first thumb rule is when, if you have to decide when I have to use Solr, so this is your indicators. When you are looking for a free text-based search with suggestions and lot of facets, and your record is document oriented. Is it clear? Just a quick way of identifying when you may have to use Solr. Guys, yeah. So this is a very useful thing because most of the time people just ask when should I use Solr and when should I not use Solr. So some of the recommendations for when you should not use, I would also just give you some basic information. So when the data is lot structured and hierarchical, so too much of structured and too much of hierarchy, and you don't need a lot of text-based search, and it has a lot of relations, okay, and you don't have to use the key-based search or token-based search, and it has a lot of transactional needs like locking a record, and it has to be consistent, even though Solr does support some level of consistency, but not to the level or the extent of what your traditional RDBMS does. Okay, and if it is too much of write dominant and little of reads. So Solr is primarily good when you have lot of reads and the ratio of reads is more compared to the ratio of writes. So Solr is a better choice. If you have more number of writes versus less number of reads, you should not choose Solr in those cases. Just a very high level best practices what you can adapt. Okay. So looking at our previous example, Flipkart example, so at the functional and non-functional features, so what kind of features do you think your search platform should support, roughly? Say for example, if you need something like Solr, what kind of things do you think it should support? I briefly explained some of those things, right? Yes, of course, it has to be really fast. So the reads has to be very fast, right? And since the documents, every document had its own attribute, so you cannot have a fixed schema. So you have to have a flexible or dynamic schema based on the document content, right? And it should have huge scale support where you can add say millions of or billions of records, and you should scale it horizontally, right? So these are some of the characteristics what we are looking in to a search engine, which we will be exploring it in Solr. Okay, fine. So we'll briefly introduce what Solr is. We'll understand what its capabilities all about. So the first of all, Solr, as you guys have might heard about it, so it is an open source Apache licensed enterprise search server. So it's in some simple terms, what it does is it takes all the Lucene libraries, and it had provided some configuration files to access those Lucene libraries and features, and provided it as a simple web application. So you can use that web application to install it into any web container and access all the services through the web container using the HTTP REST services. So in a nutshell, that's what it is. But we will explore more and more as we move forward. So as there are a lot of growth in the social media, cloud computing, and all the big data, right? So most of the time the data is keep growing, and you need a little bit more flexible options to store all the big data of massive volumes what the organizations or applications are generating. So to address all the big data needs and the scalability needs, so Solr earlier was not a big data scalable platform. When I meant not big data scalable platform, Solr was in its early stages was only limited to master-slave architecture. So master-slave architectures usually have the scalability issues because it has boundaries. After a certain extent, you cannot scale master-slave architectures. Okay, so Solr has evolved, and it has evolved into a more distributed architecture in the latest versions, and it has dropped that scalability bottlenecks or the scalability problems, and even it is now called as a NoSQL database in the NoSQL world. Okay, so as I said, so Solr in the current versions, it's also treated as the NoSQL technology, but when I say NoSQL, it is not exactly like your RDBMS storage engine or your RDBMS database. Basically, it is optimized for big data scale. So now you can distribute your work horizontally in Solr for indexing and querying purposes within the cluster in multiple nodes. Okay, so we were we discuss about how do I distribute the queries and all that stuff. Yes, we will discuss all those things. I'm just briefly introducing all these aspects. Since it is open source, you don't have to worry about buying any commercial licenses, and it is very simple web app, so it can be easily deployed and configurable. It doesn't come up with huge set of configurations. It's a simple web app WAR file. You can just dump and set the data locations. You're all set. You should be ready to run. Very simple to run. And as I mentioned, it is really scalable for lots of documents, so without any hassles. So just in case if you guys are wondering, when I'm referring search engine, it is not the search engine what we are referring to, like say Google or Bing. Google and Bing, they are completely different. They crawl websites and they index the content for searching the website content and taking it to the right place. Even though Solr has been designed and derived from the principles of the search engine, they both serve different purposes altogether. Okay, and also sometimes people has some questions like what is the correlation between Solr and SEO? In fact, there is no correlation at all. Okay, and also Solr, as I mentioned, it is information retrieval engine, the same definition what we gave it for Lucene. So it extends that and provides a lot of additional features with a lot of flexibility on the schema and distributed scale and a lot of extensibility on the plugins, and moreover it adds all the service access for indexing and querying through HTTP RESTful services. Okay, so you can access the Solr index for indexing or for querying either over HTTP RESTful services on XML, JSON, CSV, or there are few other formats which we'll be exploring. Okay. Fine. A brief history about Solr. So Solr actually it started in CNET. Okay. So in CNET, what happened was, so there was a need for adding search capability for an in-house internal or intranet website. So Yonik is the guy who derived this web app using the Lucene libraries and provided the services or HTTP so that anyone can access it. So they have contributed it to open source and it started evolving as a search platform. So in the recent 4.0, which includes the new Solr Cloud feature, is the one which is treated as the significant breakthrough in the architecture, where now Solr is more of a distributed NoSQL architecture where you can go ahead and add all those aspects of horizontal scale and distribute all the requests kind of thing. So Venkat has a question, can you also give information on security in Solr? Definitely Venkat, we are going to cover one portion, there is a topic on security and administration stuff. We'll definitely be covering that aspect there. Okay. So there is no lot of security or role-based access, or if you are expecting something like traditional RDBMS where you can restrict the content based on role, based on user, and based on operations and all, that level of security is not the concern of Solr or Lucene. Even if you would have noticed, Lucene does not tell you all those things. Some level of security can be wrapped and it can be accessed or restricted at the application to some level of operations. Okay, we'll discuss some of those things. So security is more of a convention rather than a enforcement in Solr. So there are a lot of types of securities. One is through convention and the other one is through enforcement. So the enforcement, when you code an application, it enforces you to follow that security principles because it has been coded to enforce. In Solr and in big data NoSQL technologies, we don't follow the enforcement methodology, we follow it with convention. So if there is an application which is talking internally, there is an assumption that you don't need enforcements. You can mutually agree and you can mutually have a consent saying that this security concerns I'll follow. So the application takes care of most of the security aspects, and when it deals with the data, it is dealing in a responsible way that it won't abuse or it won't hack the database. There are some things which we'll discuss how to still secure it from the applications. Okay. Fine. So let's see a little bit on the databases versus Solr. So usually databases offers you something like SQL syntax, but the Solr or Lucene also offers some level of query parser where we have seen the query syntax, but it is not the exactly same. And when it comes to partitioning and all, you may see some level of sharding in the search engines, and very effective and very stringent partitions in the RDBMSs. So most of the RDBMS follow the master slave or the cluster for load balancing and data distribution. In Solr we do follow master slave as well as the distributed or the horizontal scale NoSQL, the cloud Solr cloud model, which we'll be discussing. Consistency, it's not that strong, but it is treated, eventually it will be consistent. So there are no concepts of foreign keys or constraints kind of a thing. So in traditional databases, you can put constraints, you can have relationships, you can have constraints on the columns. So Lakshmikant has a question, what is sharding? Okay, fine. Sharding is nothing but, say, if you have a huge table of data which cannot fit everything into one table, it is similar to partition. Sometimes people also refer it as shards. So table partition is nothing but physically they separate the table content within the same physical hardware in the same database. When it comes to shards, shards does not recommend to separate the same data in a same physical machine. Rather, it separates the content onto a totally complete different machine. So it's like the same table, half the data is in machine 1 and half the data is in machine 2. That's the basic difference. So, but when you access through a framework or a platform, so for the application or for the user, it is seamless and the user doesn't know that it is in 3 machines, and it seems like you are querying a system and you are getting all the data from one place. So you keep sharding the data based on the size or based on the range of the tokens and all that stuff. The partitions, it is a little bit different. So it can be also stored in different machines, but most of the time it is only the splitting of the table into smaller chunks, but not on the focus is not on splitting into machines. Primarily the both are used for similar reasons, just to keep the data size smaller. Fine. So the transaction concepts, RDBMSs are very strong in asset properties, but when it comes to Solr, it is more of a optimistic locking, and in databases they are pessimistic. So databases are more proactive in locking, and Solr is more of a optimistic, so that there could be a lot of flexibility and room in multiple threads reading or writing into the same content. Okay, so in pessimistic locking, so once a table or record is locked, no other session or no other user can access. But in optimistic locking, so even though if someone is locking, so it is allowed to you to write from all the sessions at all point of time. So after that, the merging and the updating happens based on the recorded timestamp of that version of the data on that particular record. Okay, so Lakshmikant has a question. Can I use Solr as OLTP? I mean, for more frequent reads and updates. Absolutely no. If you have a OLTP kind of a need, Solr is not the right choice. So Solr is recommended when you have read dominant ratio versus write. And that too definitely not OLTP needs. OLTP is like online transactions. So you cannot run huge online transactions like booking, flight booking. So what people usually do is for searching and displaying, they use Solr. When they go for booking or placing the order, they use a traditional databases. So in large scale applications or systems, there is no one single database which will provide all these features. You have to use a hybrid of databases. Okay. So in fact, Solr also provides a lot of concurrent reads and writes. And when it comes to speed of reads, Solr is much more faster and much more efficient in reads, but it is a bit slower in writes because it has to index the content, and it would be definitely bit slower, not bit, in fact very pretty much slower compared to your RDBMS. Okay, so that was just the high level overview of the RDBMS and the Solr. So some of the features which we've already spoken, so just to give, so it is full-blown full text search capability with a lot of features like suggestions, highlighting, spatial search, facets, grouping, joins, lot of other things. Okay, and it is optimized for web scale. Everything can be accessed over HTTP REST services, XML, JSON, HTTP, and few more other formats. And you have a lot of administrative interfaces to manage and control the Solr cluster or the interface. Everything, all the basic statistics can be accessed through the JMX monitoring, and it has a lot of scalability by having auto failover, lot of replication and all that stuff. So we had a question like, is it really good for me to have Solr if I have a need of a real-time OLTP where I have frequent reads and updates happening? In fact, I would recommend not to use it, but still Solr claims it to be providing the near real-time indexing. So when I say near real-time indexing, it is not immediate, but it is still faster. Okay, so it may happen in few minutes in some cases based on the documents and based on the size, and it may take few seconds as well. But compared to traditional RDBMSs, most of the times it would turn back within few milliseconds. So that's a basic difference. And as I said, it has everything configured and customizable through XML configurations and a lot of extensible plugins as well. So some of the features which I did not mention is like you could do pagination, sorting, spell checking, geospatial search, and all that stuff. So we have seen the briefing of faceting, highlighting, and synonyms, stop words. Everything, whatever we have seen, can be done in Solr. The way how we used to do in Solr is by writing Java code. But in case of Solr, everything can be configured in XML configurations. Okay. And one thing which we have not seen in Lucene is there is a lot of features like spell checking, auto suggestions, which will be very handy in most of the cases when the user is typing something wrong and I would like to correct him and ask him, is this what he's meant? Okay. So if I had to divide the features, so I would divide it into three sections. So the user experience features like the pagination and sorting, the faceting, which we will explore it more in detail, but we have seen a glimpse of it in Lucene and also using the flip cart example. So the auto suggestion is nothing but the drop down. This is what we are referring when I'm saying autocomplete. So when I'm saying quad core mobile, I'm getting a list of recommendations. Exactly, is this what you are looking by looking into some of the common documents which people are searching. So spell checking is if someone is typing some wrong word, so it would recommend me the exact the exact words with the right spellings. Highlighting is basically you highlight the term in the document when you get the results back. Special search is basically used for location-based search and most of the time on the lat long. So the data modeling is basically like grouping, collapsing the field, and the flexible query support, joins, document clustering, importing rich documents using the Solr cell, and importing data from relational databases, and a lot of multi-language support. So we will see some of these features. User experience features will explore everything. Data modeling will see most of it, whatever is required for our application. And in Solr 4.0, there are some features like near real-time read and near real-time indexing. We'll explore all of those concepts, and real-time get, transaction logs. We'll see how do we do the 4.0 architecture with sharding, replications, and Zookeeper. We'll cover all of these topics. Okay, most of it. Fine. So we are saying Solr extends Lucene. So it has most of the things exactly the same with additional features. Okay, so you could have all the types, whatever Lucene supports, directly available in Solr, and you could have the same Lucene query language with some additions to it. A lot of faceted and filtering aspects which is enhanced, and a lot of geospatial features also extended, and all the API coding is done through configurations. So the class choosing which analyzer, which filter, all that stuff is configured in XML. And moreover, you have a lot of administrative UI where you can use it. So I think we have seen this. So it is near real time for faster search and index. You can distribute the search or index across multiple nodes in the distributed environment or in Solr Cloud kind of a setup. So as I mentioned, there are multiple formats. We will see that other than JSON, XML, CSV, and you can directly also get the few language code like PHP as the response from your Solr server or Ruby kind of things. And you can also import a lot of rich content, and you can have a lot of plugins as well. Great. So just a very few. I'm not going through the entire list. Most of the big companies are using Lucene. This is just Lucene Solr. This is just a small list. Maybe there is a huge set of people who are using it. Yeah, maybe I think there is a lot of people, in fact. I'm not sure if this list is the updated one, but in fact there are a lot of people who are Solr implementations in their organizations for search needs.